Hello, students. Today's video is titled Adding and Subtracting Mixed Numbers with the Least Common Multiple, aka LCM. And I just want to be totally honest here. The way I'm going to have us do this year might be a little bit different than the way your elementary school teacher did it, but I need you to trust me, this is how we're going to proceed. So when you're trying to add or subtract, I just chose an addition problem, but subtraction works just the same. When you're adding or subtracting mixed numbers, right? So you have your whole and then your proper fraction. What I want you to do before you proceed with finding a common denominator, I want you to make these improper. So for example, if we're going to add 1 2/3 plus 2 1/4, we're going to make them both improper by taking 3 times 1 plus 2 and writing that as 5/3 plus, and then we're going to take 4 times 2 plus 1, and that's going to give us 9/4. Now the lesson looks exactly like yesterday's lesson. We're simply adding two fractions. These are no longer mixed numbers. So we're going to come off to the side and we're going to go ahead and find our least common multiple, right? So we're going to take the denominators 3 and 4. And we're going to push out a couple multiples until we find something they have in common. So let's go. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. We could keep going, but I'll stop there for now. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. We could stop. We've got a match. 12 is the least number they have in common, the least common multiple. So let's bring that 12 back over here. So now we have a 12 and a 12. That's our common denominator. That's why I'm putting it on the bottom. Now we have to grow our fractions up. So we need an equivalent fraction to 5/3 that has a denominator of 12. So we look at the denominator 3 and we ask ourselves, 3 times what number grows to 12? And that's 4. And then we do the same thing up top. 5 times 4, 20. And on this side, we look at the bottom, 4. How does a 4 grow up to a 12? Well, you multiply by 3. And then 9 times 3 is 27. And so now 20 twelfths plus 27 twelfths is 47 twelfths, because we're just adding the 20 and the 27. And that's a great answer, except that it's improper. This is improper, and we don't want to leave our answers improper. So let's change it back to what we started with, which was mixed numbers. Let's go ahead and use some long division to take 47 divided by 12, and we'll cover this up. So we ask ourselves, does 12 fit into 4? Well, no, 12's too big to fit into 4, so we'll X that out. Now we'll reveal the 7. Does 12 fit into 47? Yes, actually more than a few 12s fit into 47. In fact, 3 12s will fit in. I almost thought it was 4, but if we remember, 12 times 4 is 4 times 2 is 8, and 4 times it's 48. That's just a little bit too high, so we have to back it down to 3. And 3 times 12 is 36. And when we subtract, 7 minus 6 is 1, and 4 minus 3 is 1. So our final answer to this addition problem is going to be the mixed number 3, because our whole is up here, 3 and 11 twelfths, because we go top and bottom and side. So 3 and 11 twelfths. So final answer, 3 and 11 twelfths. Now, the reason I said what I said in the beginning, and especially like if parents are watching this, like when I first started teaching 6th grade a few years ago, my students came to me and they said, hey, our teacher let us, when we would add and subtract fractions, like our teacher would let us keep them as mixed numbers, and they would let us like add the whole parts together. So like you would add that and get a 3, and then we could just deal with these fractions and then add those together and get that part. And that will work. Like that's a fine way to do it. It's just not the way I prefer to do it. The trouble is when you get into subtraction, sometimes when you're subtracting with fractions and whole numbers here, you have to end up borrowing. And I did teach it. I allowed my students the first year. I was like, yeah, let's just do it. Let's go with what you learned in elementary school. And it's a little troublesome because it's just more steps to remember. And in my experience, I have found that the less steps to remember, the better. So since I've already taught the kids how to add proper fractions together, and this is the method I use, I think it will be less confusing for them to just stick with that method. So the only new step here is starting by making your fractions improper and then proceeding. So I do not want to keep them as mixed numbers. I just want to do them improper and proceed the way I would with any other fraction, and subtraction works the same way. So thanks for watching. I hope that made sense, and happy trails to you.